In this part, we will discuss about the recent development in anode. The lithium-ion battery has the advantages of high energy density, long cycle life, the small occupied volume, and high discharge voltage. Despite of all these advantages, it has the biggest issue, which is the safety issue. Solid-state lithium-ion battery use solid-state electrolytes are considered next-generation advanced energy devices, which are expected to fundamentally solve the safety problems of the conventional lithium-ion battery. According to a research article, lithium metal is mainly used as an anode material in the research of solid-state lithium-ion batteries. During battery cycling, the lithium, despite of all the advantages, has the biggest issue, which is the dendrite formation, which badly affects the life cycle of the battery. Dendrite formation produced on the surface of the lithium metal will also penetrate the solid electrolyte, so it also threatens its battery safety. Therefore, it is necessary to develop non-lithium metal anodes for solid-state batteries. So scientists are trying to make such type of solid-state batteries. We do not use lithium but use carbon, silicon, and other metal hydrides and lithium titanate. So there are some challenges which can be faced in the manufacturing and scaling of solid-state batteries. Basically, these challenges are somehow related to its cost. The first one is manufacturing complexity, the second one is electrode fabrication performance, and the third one is material compatibility. The first one is manufacturing complexity. Solid-state battery involve more complex manufacturing processes compared to conventional lithium-ion batteries. The fabrication of solid-state electrolytes, electrode material and interfaces require precise control of material deposition. Basically, fabrication refers to a process of creating, manufacturing a product. This involves the process of combining and shaping different materials and components, which is obviously a complex procedure. So it is also used in solid-state battery, which results as the biggest challenge, as it is also time-taking as well as it also results in expensive process. The second one is material compatibility and integration. Solid-state battery consists of various layers and interfaces. Material compatibility is the most important thing, otherwise some interfacial reactions start, which can be in between electrode to electrolyte, electrode to electrolyte, or this also results in the reaction between electrolyte to electrode and also results in interfacial resistance. Electrode fabrication and performance. Solid-state batteries require electrodes that can accommodate the volume changes that occur during charging and discharging. Basically, in solid-state batteries, during charging and discharging, there are some volume changes. So there is a material required which can accommodate all these changes. So scientists are trying to make such materials. There is another topic, which is integration with existing battery technologies, or its comparison with existing battery technologies. The first one is manufacturing process. Solid-state battery may have different manufacturing requirements and material compared to existing battery technology. Integrating solid-state battery into existing manufacturing processes could involve modifying production lines or developing new manufacturing techniques. It's also a biggest headache, and it's also a complex process. The second one is voltage levels. Solid-state batteries typically have different voltage characteristics compared to lithium-ion batteries. They have highly changed voltages matching circuits or voltage comparing technologies may be required to ensure compatibility with the existing electronics or charging infrastructure. Now we will discuss about the cost consideration, which is very important in manufacturing any battery. The first one is materials. Some materials are very costly, which can result in expensive process. Some solid-state battery designs use more exotic or rare materials. Rare materials are very hard to find, so it also results in expensive process. And the second one is scale of production. Basically, the solid-state battery are not produced at the same level as lithium-ion batteries. Large production helps reduce cost or economics of scale, but the limited production capacity for solid-state batteries results in higher cost per unit. Applications. So there are some applications which are used in different vehicles. Different applications are here: electric vehicles, consumer electronics. The third one is energy storage system, and the fourth one is medical devices, and the fifth one is aerospace and aviation. First one is electric vehicles. Solid-state battery offer high energy density, faster charging rates, and improved safety compared to lithium-ion batteries. That's why they are used in electric vehicles. Basically, the solid-state batteries have the higher potential for fast charging as compared to lithium-ion batteries. So, electric vehicles also require such type of material which have faster charging rates. So that's why they are used in electric vehicles. Vehicles can be charged in a fraction of the time more required for the current lithium-ion battery technology. Making electric vehicle convenient practically for daily life. They are also used in portable electronics such as smartphones and tablets, which are very common nowadays, and some wearable devices. First of all, we will discuss about smartphone and tablets. Solid-state electronics form the backbone of smartphones and tablets, and this is the need of the day. We need tablets and smartphones. So this is the most important application of solid-state batteries, and some wearable electronics, wearable devices such as smartwatches which you can wear, and some sensors, wireless communication modules, and solid-state batteries to deliver functionalities like health monitoring. It is the most important and the most successful feature of the solid-state battery, activating tracking, notification, and augmented reality experiences. They are also used in laptops and ultrabooks. Solid-state battery electronics play a crucial role in laptops and ultrabooks, offering faster performance, lower power consumption, and improved reliability as compared to traditional liquid-based electrolyte. How they are renewable energy storage. Solid-state batteries have sufficient or significant potential for application in renewable energy storage system. There are some key applications of solid-state battery in renewable energy storage. We need such devices, we need some resources which are renewable. So there are also renewable energy storage. So first one is grid scale energy storage. Solid-state battery can be utilized for large-scale energy storage systems connected to electrical grid. These systems can store excess energy generated from renewable sources such as solar and wind during periods of low demand. Solid-state batteries have high energy density and long life cycle, make them well suited for such grid scale applications. So they can be used in a very long time. Second one is off-grid power system. Solid-state battery can be used in off-grid power stations where renewable energy sources are the primary and the sole power generation source. These systems, such as remote cabins and rural electrification projects and mobile power stations, can rely on solid-state batteries to store and supply energy. Solid-state batteries have high energy density and also have a longer life cycle, which also results in use in off-grid power systems. Conclusions: there are some advantages as well as some challenges in solid-state batteries. So, why we should prefer solid-state battery over liquid or gel-based electrolyte batteries? So, there are some advantages of it. The first one is higher energy density. Solid-state battery have higher energy density as compared to traditional lithium-ion batteries because its product is very stable. It also have a fast charging times. Solid-state battery can easily charge, so in a very low time, in a very fast time. So they are used in laptops and as well as in our smartwatch, and the most important application, which is electric vehicles. They have the longer lifespan as well, so they can be easily used in electric vehicles, and they are using in electric vehicles. Third one is longer life cycle. Solid-state battery generally exhibit longer life cycle and improved durability, allowing for a higher number of charging and discharging without significant capacity loss. The fourth one is environmental friendliness. Solid-state battery typically use non-toxic and environmental friendly materials, making them a general alternative to conventional batteries. Nowadays we should use some as materials. We should use such materials which is environmental friendly. So to make our living worth living. So solid-state battery use such type of materials which are very environmental friendly. So this is the reason we should prefer solid-state battery over traditional lithium-based batteries. Okay, now moving to the challenges of solid-state battery. The first one is cost, its scalability, limited operating temperature, scale of production, and material compatibility. The cost is the most important thing, and there are many reasons for it. Basically, such materials are used in solid-state batteries, which can be rare, and to find such materials there must be a cost required. There must be an expensive process, so that's why it's very expensive. As well, cost control, especially in solid-state batteries, especially those based on advanced materials like garnet electrolytes are used, which can be more expensive. So this results in high cost. The second point is scalability. Currently, solid-state batteries are not produced at the same cost as lithium-ion batteries. Larger scale production reduces cost through economics of scale, but the limited production capacity for solid-state results in higher cost per unit. So to produce anything on a higher scale, there should be low cost, which is not in solid-state battery. As well, there is no large-scale production, which also increases cost. And material compatibility is also the most important thing. Such materials are used in solid-state battery, which requires the more expensive materials for their compatibility, which results in higher rates. Despite these challenges, ongoing research and development efforts are aimed at addressing these issues and advancing solid-state battery technology to make them commercially viable for various applications. Now, we will see the potential development. Solid-state battery is one of the most promising solutions for the future generation of the batteries. Embedded researchers have developed mixed ion electron conductors as well as electronic lithium-ion insulators. This is a very biggest development in nowadays. It is a 3D honeycomb architecture with nanoscale MIEC tubes. These tubes are filled with lithium, which forms the anode. Basically, in this experiment, they use lithium, but this lithium does not form dendrites. Okay? A key part of this discovery is that the honeycomb structure allows lithium to expand and contract during charging and discharging. This breathing of the anode avoids cracking of the battery. The coating of the tubes acts as a barrier to protect them from the solid electrolyte, which is basically a more an achievement of them. Future outlook. For some time, solid-state batteries have been seen as the next step in electric vehicle development. There are more of an inherent chemical defect exists in solid-state batteries after several charging and discharging. There is a volume issue, so also by using lithium, there are some lithium dendrites. So scientists are trying to make all these challenges to zero scale, and also trying to resolve all these issues. Moreover, an inherent chemical defect exists in solid-state batteries. After several charging and discharging, they begin degrading due to the buildup of lithium dendrites, which are tiny, twig-like lithium particles that grow and can penetrate the battery, leading to short circuits and other issues. There is a link of the article. You can find the articles related to solid-state battery from this link. Thank you for your attention, and thank you for your kind attention.